Welcome to Structural Engineering Online. We are dedicated to provide teaching and learning support through video lectures. Please subscribe to our channel if you have not yet subscribed. Thank you very much. In this lecture, we will learn how to determine the stability and determinacy of simple truss. You know that the truss is a structure in which the members are joined together by smooth pins. As every smooth pin will give you only two equations of equilibrium, sigma fx equal to 0 and sigma fy equal to 0. Another condition for the simple truss is that all loadings are applied at the joints. These are the conditions for the simple truss. Now the simplest form of truss that is rigid or stable is a triangle. So if we get a triangular shape, you can easily say that okay, this can be stable structure. These sides will remain as it is. Now we look at the conditions for stability and determinacy of this truss. Here we have this condition if B plus R is equal to 2J. Now what is B? B is the number of bars in the truss. Number of bars means these rods. R is equal to the support reactions and J equal to number of joints. So if you find that number of bars plus the support reaction is equal to 2 times the joints, as I told you earlier that every joint will give you two equations of equilibrium. So that will give you the number of equations available for solving these unknowns, because B, the force in the members, because it will be only axial force, one force in that member, and R, so these are the unknowns for the structure, internal forces in the members and the external support reactions. Another thing is that B plus R greater than 2J. If we find that B plus R is greater than 2J, then we'll call it as statically indeterminate. So if B plus R is equal to 2J, is statically determinate. If B plus R is greater than 2J, it is statically indeterminate. And if B plus R is less than 2J, then we call it as unstable structure. Another instability you have seen in the previous lectures when the support reactions are concurrent, or when the support reactions are all parallel, then also we call that structure will be unstable. Here this is about the internal stability. Now we look at these examples. If we look at the first one here we have these two reactions at the hinge and one reaction at the roller. So we can simply say that it will be unstable because these three reactions will be concurrent here and here. If we extend the line of this force, this reaction, they are meeting at one point. So this is unstable, okay, because the reactions are concurrent. Another conditions for external stability, if you see here, these three reactions in the second figure all are rollers, so the reactions are parallel, these three reactions are parallel, so this is also unstable. Now here if we see in this case, here how many reactions are possible, although this is hinge support, here it is hinge and here it is roller, so total reactions will be equal to 3. And how many bars are there? If we count here the bars, number 1, 2, 3, 4, 5, 6, 7, 8. So 8 bars are there and reactions equal to 3. And if we count here the number of joints, we have 1 joint, 2, 3, 4, then 5, 6. So joints are 6. Now we will check. B plus R is 8 plus 3, that is 11, and 2J, because it is 2 into 6, so this is 12, right? So B plus R, which is 11, and 2J is 12, so we can say that this is also unstable. So this is because of this arrangement of these members. You are not getting a rigid frame. In that case, we can say if we add one member here, then it will become stable. Okay, now we'll solve some more examples and see how easily we can determine the stability and determinacy of our structures. If we look at this structure here also we can look for the joints, number of bars, and the reactions. So hinge will give you how many reactions? Hinge will give you 2 reactions. Roller will give 1 reaction. So we can say that R is equal to 3. And these reactions are not parallel, these reactions are not concurrent. So we can say that it is stable externally. Means the reactions are not parallel and not concurrent. So if R is equal to 3 and equations to solve for these reactions are also available, E equal to 3. So we can say that R is equal to E. So this is externally determinate. Externally determinate. Okay. Now we look for the internal stability and determinacy, and for that we have to count how many bars are there. So B equal to how much, and for that we check number of bars 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So B equal to 19. So B plus R we can calculate easily. B plus R is equal to 19 plus 3 is equal to 22. Now we look for the joints, because to check for the internal stability we have to check whether B plus R is equal to 2J or B plus R is greater than 2J or B plus R less than 2J. Now the joints we will count here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So joints equal to 11. So 2J will be equal to 22. So we can say that B plus R is equal to 2J. Therefore, this is internally determinate and internally stable. So it is internally stable and determinate. Right. Now we come to the second structure here. And in the second structure also we will see that how many reactions are there, how many bars are there, and how many joints. This is the procedure what we have to do for our structures, which is truss. So here also we can see hinge will have 2 reactions, roller will have 1 reaction. So R is equal to 3, and these reactions are not concurrent and not parallel. So R is 3, and the reactions which are non-concurrent and non-parallel, so structure is externally stable and determinate. We can calculate the reactions which are 3, and we have the equations also equal to 3, right? So because R equal to the number of equations, for the truss 3 equations are available. Now we calculate how many bars and how many joints are here in this truss. Okay, we will count here. Bars 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So number of bars are 12. So we write here B equal to 12. Now how many joints? Okay, joints I will count with red. This is joint number 1, joint number 2, joint number 3, 4, 5, 6, 7 and 8. So joints equal to 8. Now if we calculate that in that equation b plus r, so we find that b plus r will be equal to, b is 12, r is equal to 3, b plus r is equal to 15, and 2j, that is 2 into the joints, 2 into 8 is equal to 16. So now from here we find that b plus r is less than 2j. So this is unstable, right? So now we go to another example. Here we have a truss in which there are two hinge supports here. So we will have r equal to 4, but equations, how many? Equations only 3 for one truss. So to calculate the reactions, you can say this is externally indeterminate, because support reactions are not internal, these are external forces which come from the supports. Now we look for the internal stability and determinacy. So for that we have to count how many bars and how many joints are there. So bars how many and joints how many. So first we count the bars. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So bars are 15. Now we count the joints. How many joints are there? Okay, joints I am writing with the red color. So 1, then 2, 3, 4, 5, 6, 7, 8 and 9. There is no other joint. Okay, so these two rods are overlapping, so we will not consider this as the joint. This is not a joint. So joints are 9. So now we count b plus r, which is how much? 15 plus 4, 15 plus 4, 19. 2j is equal to 2 into 9, that is 18. So now you find that b plus r is greater than 2j, therefore the structure is statically indeterminate. So now you've seen that with the help of these explanations, I hope you have learned how to calculate the degree of indeterminacy of any structure, whether it is a truss or a beam. The previous lecture was about the beam. If you have not seen, I advise you to see that previous lecture for stability and determinacy of beams. We can also provide the link in the description for that previous lecture about the beams. I hope this lecture has helped you in learning to determine stability and determinacy of truss. You are also requested to click on the button for like and share it with your friends so that they can also get the benefit. And please subscribe to our channel so that in future when we upload any video lecture, you will get the notification. You are also requested to write some comments if you need some more lectures. What are the topics that you would like us to upload the lectures? We will be happy to get your feedback and comments. Thank you very much.